Hello, students of Hays High School FST classes. Here's what I need to do with you today. I need to continue on today with your Day 3 class notes. Miss Dina and I decided to split this up into 2 days, kind of give you a break and really let it be a unit that we're really understanding. So what you'll need in front of you is last time's class 3 notes. We'll continue from problems number 19 on. You'll need your note card, even though it's not going to be as needed today as it was last time. And then I'll also let you know you need to make sure you get in and get your homework quiz made up. We did take one of those today. So here's where I need to start with you today. If you would, come over to your page wherever it says these examples there, where it says the double angle formulas. I need to show you where they come from. These are based off what we did last class, when we did the sine of alpha plus beta or the cosine of alpha plus beta, those kind of formulas that we talked about last time. Well, I'm going to use those to talk to you about what happens if we're working with the same angle. So hang with me for just a second. If you would, look back at your note card for your sine. I'm going to rewrite sine of 2 theta as sine of theta plus theta. Now I'm going to apply the material on your note card that we did last class, where this now becomes my alpha, this becomes my beta. So when I do that, sine of 2 theta becomes sine of theta times cosine of theta plus cosine of theta, sine of theta. I just applied the formula that we used last class. If I simplify this now, guys, I'm going to get sine theta cosine theta plus cosine theta sine theta. I'm going to get 2 sine theta cosine theta. If you look at your note card, notice that we have a formula for that now. That's simply where it came from. The good news with the sine 2 theta, this is the only formula, that's your only choice. Unlike the cosine, you're going to have choices for it. Let me show you where the main formula comes from. I'm going to think of cosine of 2 theta as cosine of theta plus theta. I'm going to apply, this becomes your alpha, this becomes your beta. So once I apply this, I'm going to get cosine theta times cosine theta minus sine theta cosine theta, or sine theta again, sorry about that. If I simplify this, I'm going to get cosine squared theta minus sine squared beta. That's one of our formulas for cosine of 2 theta. That's the least used formula of all of them. But that is one of them. If you look at the top of your note card, you got cosine of 2 theta equal cosine squared theta minus sine squared theta. Now let me show you real fast the 2 main formulas that we get though for cosine of 2 theta. Let's take cosine of 2 theta real fast equal what we just derived, cosine squared theta minus sine squared theta. I'm going to do a little bit of substitution here. If you remember what we did 2 classes ago, we have sine squared plus cosine squared equal 1. That's your top Pythagorean identity. If you flip your note card back over on the back side of it, we simplified that. So I'm going to give you another name for cosine squared. If you look at sine squared plus cosine squared equal 1, another name for cosine squared would be 1 minus sine squared. So I just did a little substitution there. And I still have this sine squared. If I simplify this, I'm going to come up with a second formula for cosine of 2 theta. And that formula is going to be 1 minus 2 sine squared theta. So now I got 2 formulas for cosine of 2 theta. We will use this formula whenever we're given a sine value. Picture this now. Let me show you where the third one comes from, and the last one. This will be our last formula of the day, by the way. Cosine of 2 theta, I'm still going to think of that as cosine squared theta minus sine squared theta. But this time, instead of replacing the cosine squared, I'm going to leave it alone, and I'm going to replace sine squared with 1 minus cosine squared. Once again, the Pythagorean identity. If I simplify this, I get cosine squared theta minus 1 plus cosine squared theta, since two negatives make a positive. So here is a third formula for cosine of 2 theta. It's 2 cosine squared theta minus 1. You'll see pretty dang soon why there's 3 formulas for cosine. We will use this formula when we're given a cosine value. You'll find as we go, you could use any of these 3 formulas for cosine, but of course we want to do it the easiest way. So guys, if you would, pop over to your number 17. I'll kind of click through these. I don't know that you'll need all the examples, but I'll sure show them to you. It says find the exact values of sine theta or cosine theta, so whatever you're given, find the other. And then on part B, we're going to find sine of 2 theta. And then we're going to pause and we're going to find the value of cosine of 2 theta. And of course, show all your work. Here's where we want you to start. Come over here first and draw yourself a reference triangle. In this case, it's telling me I need to be in the second quadrant. So there's my reference triangle. Fix that reference triangle to where the sine is 4/5. So there's 4, there's 5. Now, use the Pythagorean theorem to obtain this other side. Since you're given the hypotenuse, I'm going to go 5 squared minus 4 squared is going to give me this other side squared. So it looks like this is going to be 9 equal x squared. This value must be 3. Now, I'm not totally done with that. Notice that it's going to the left, so really this is a negative 3. So over here on part A real fast, since we're given the sine value, we're going to find the other, so we're going to find the cosine value. So the cosine of theta is going to be negative 3/5. Now here comes the new part of the day, but it's really pretty easy. On part B it says find sine of 2 theta. Well, if you look at your note card or just remember what we just derived, sine of 2 theta is 2 times sine of theta cosine of theta. Plug in your values now. I'm going to have 2 times the sine value, which is 4/5, the cosine value, which is negative 3/5. I'm going to put that over 1. If I simplify this, I'm going to get that the sine of 2 theta is going to be, I'm just going to multiply straight across, negative 24/25. That's all there is to that one, guys. You can run it through your brain or your calculator. Now, for part C, we're asked to find cosine of 2 theta. To be truthful, you can use any formula for cosine of 2 theta that you want. Any one of them would work. But what I'm going to do, since we were given the sine value to start with, I'm going to go pick the formula from cosine of 2 theta that has a sine in it. So the one I'm going to pick is I'm going to use 1 minus 2 sine squared theta. Now I'm going to plug in the numbers. So I've got 1 minus 2. My sine value is 4/5. I need to square that. So this really becomes, and you can type that in your calculator now if you want, but this really becomes 1 minus 32/25. I squared the 4, I squared the 5, then I doubled it. So I'm going to get cosine of 2 theta to be negative 7/25. We want these left as fractions. Don't leave them as decimals. Well, we don't want them as decimals, period, because not all of them will be nice numbers. So, but there's the steps that we're going to do, guys. We're going to draw out our right triangle, and then we're just going to pick which formula to use. If you would have picked one of the other formulas for cosine of 2 theta, you still would have got the correct answer. Okay. So here goes your number 18. It says sine of theta equal 3/4, and we're in the first quadrant. So let's come over here. In the first quadrant, draw a reference triangle. Fix it up to where the sine is 3/4. Be careful finding the other side. It is not 5. My hypotenuse is 4, so that's my largest. So I'm going to go 16 minus 9 is 7. This value must be the square root of 7. Now, since we started off with the sine value, let's go get our cosine value real fast then. So it looks like cosine of theta is going to be radical 7 over 4. So I'm done with part A. For part B now, to get the sine of 2 theta, I'm going to use the only formula that we have that says 2 sine theta cosine theta. So I'm going to have 2 times your sine value of 3/4 times your cosine value of radical 7/4. Multiply straight across. I'm going to get 6 radical 7 over 16. But notice the 6 and the 16 reduce. So I'm going to get 3 radical 7/8. So let me come over here and write my answer. Sine of 2 theta is going to be 3 radical 7 all over 8. That's all there is to it. Here's part C. Cosine of 2 theta. You pick which formula you want. Since we were given sine of 3/4, and 3/4 looks easier than radical 7/4 to work with, I'm going to use the formula that says 1 minus 2 sine squared theta. I'm going to have 1 minus 2. Sine happens to be 3/4, so 3/4 squared. You can run all this through your calculator. Since I'm not going to touch my calculator, I'm going to think of this as 1 minus 18 over 16. So I'm going to get negative 2/16, so negative 1/8. So cosine of 2 theta is going to be negative 1/8. So guys, that's all we got going so far. We'll pick the formula and then go from there. I'm going to go ahead and skip number 19 because I think that's really pretty easy. You would draw a triangle in the first quadrant once again. You'd fix it up to where the sine is 2/5. This side would be 25 minus 4, square root of 21, and then go get your 2 answers. Okay? But let me jump over to number 20 because it deals with the cosine, it deals with a different quadrant, but the steps are not going to change. So here goes our number 20. Cosine of theta equal negative 12/13. Theta is between 180 and 270 degrees. So something I know, I must be in the third quadrant. Cosine is the adjacent over the hypotenuse. To get this other side, here's my hypotenuse, so I'm going to go 13 squared. I don't want that thing in my way. I'm going to go 13 squared minus 12 squared. Whatever that is, I'm going to square root it and get a 5 right there. So I'm going to get a 5 right there. Now, before I move on, make sure you don't mess up on these guys. Tell me something about that 5. It should be negative. Okay? So on part A, we're ready. I know that the sine of theta is going to be negative 5/13. And if you can't read that, that's negative 5/13. And I have no idea why that keeps bopping him away. Now let's go to part B. Sine of 2 theta. We're going to use the only formula that we know. 2 times the sine value, negative 5/13, times the cosine value, negative 12/13. Multiply that straight across, guys. 2 times negative 5 times negative 12. Looks like 120 over 169. So let me come over and write the answer. Sine of 2 theta is going to be positive 120 over 169. Let's go get cosine of 2 theta. Really, this is the only one you have to think on a little bit. Since I'm given the cosine value, I'm going to use the formula that says 2 cosine squared theta minus 1. If you were in class, you would have heard myself and Miss Denahan repeatedly say it really doesn't matter which formula you use, you're going to get the same answer. So I'm going to have this now. I'm going to have 2 times negative 12/13 squared minus 1. You can run this 100% through your calculator. If you do, you're going to get 119 over 169. What I did in my head is I went negative 12 squared is 144, doubled, so I had 288 over 169. I thought of 1 as 169 over 169, and then I subtracted the 2. So let me come over and write my answer. Cosine of 2 theta equal 119 over 169. Okay. Looks like I've got one more to go, guys. My video is going to be about a whopping 20 minutes is all. So here's number 20. It's got a radical in it, or number 21. It's got a radical in it. Big deal. Theta is between 270 and 360.